Next is height of projectile. Again, we draw the figure of projectile motion thrown with velocity, initial velocity u at an angle of theta. So x component of velocity is u cos theta, y component of velocity is u sin theta, acceleration along x-axis is 0 and acceleration along y-axis is minus g because g is acting downward. It is opposite of the conventional our direction, that is positive taken along the positive y-axis. This is the, if it thrown at the time t equal to 0, then from point A, then it reach at point B at the time capital T. This is the time of flight. That means maximum height will be at t equal to t by 2. So we have to find what is the height covered by the projectile at the time t equal to t by 2. At this point, it only has the horizontal component, where the y component, this is the v, say velocity is v, so it is having only the v x direction, component of velocity along the x direction, while the vy is 0 at top highest point. So we have to use the equation of motion, and say we use equation of motion along the y-axis. There is a second equation of motion, s equal to ut plus half at square. When we use this equation of motion along the vertical direction, then this s will give us h equal to initial velocity uy and time taken is t by 2. This is the time taken by the projectile to reach from A to this highest point. That is, it is the t by 2 plus half. Acceleration is along the y direction is minus g. So it is minus g into again t by 2 square. And now we have to solve it. Uy is u sin theta. U sin theta into t, time of flight we have already mentioned is 2u sin theta by g, which we have derived. So t by 2 is u sin theta by g, and we put this value here, u sin theta by g minus half g, we bring this half outside, and then u sin theta by g square, and simplify it. It is u square sin square theta by g minus half into u square sin square theta by, this is g square, this is g, one g cancel, remaining g. That means this is 1 of u square sin square theta by g, it is half of u square sin square theta by g. That is, we will leave with u square sin square theta by 2g. That is 1 minus half, that is half. This is the formula for the height attained by the projectile. This is the maximum height attained by the projectile during its motion. This formula is important. We have to remember this. This is one of the note is that this h will be h maximum. That means for same initial speed, what will be the maximum height, or what is the angle for which we get the vertical height maximum. So for achieving the maximum height by varying the angle theta, it will be equal to, because we have already mentioned that sine theta is the maximum value of the sine theta is 1. So sine square theta is also 1. It will be equal to u square by 2g when sine theta is equal to 1. This is the maximum value of sine theta. So sine square theta. And sine theta equal to 1 means sine pi by 2. That means maximum height will be attained when theta equal to pi by 2 or 90 degree. That means we can say if an object is thrown horizontally with 45 degree, we get the maximum horizontal distance, that is the maximum range. And if an object is thrown at an angle of pi by 2 or 90 degree, we get the maximum vertical height, that is the h max, and it is equal to u square by 2g. So in this way, we find three formulas which are very important from the projectile point of view, and questions are based on these formulas. One is time of flight t equal to 2u sine theta by g. Second was range r equal to u square sine 2 theta by g. And third one was h equal to u square sine square theta by 2g. Next, we have to find the trajectory of the projectile. Regarding the trajectory, we have already mentioned that trajectory of the projectile motion is a parabolic path. So we have to find the equation of trajectory. With the equation of trajectory, we can say the path is parabolic. Trajectory of the projectile. Again, we draw a graph of the projectile motion thrown with the initial velocity u at an angle of theta. Trajectory means it is the relation of y and x. Say y is a function of x. Relation of y with x is called the trajectory. This is x-axis and this is our y-axis. So, and we already found that ux equal to u cos theta, uy equal to u sin theta, ax equal to 0 and ay equal to minus g. If I take some point here, say this is A, this is B, and say this is point C, then velocity at this point is let A V. So how we can relate this u and v? To relate this u and v, we again take the component of this v also. This component of u is u cos theta, which we have already mentioned, and component of u along vertical direction is u sin theta. Similarly, component of v along x-axis, say this v makes an angle alpha with the horizontal axis, so it will be v cos alpha, and this component will be v sin alpha. We have already mentioned that there is no acceleration along the x-axis. That means in absence of acceleration, velocity will not change. Therefore, we can write that u cos theta equal to v cos alpha. This is the first equation which we have to remember, that horizontal component will be same. That means we can write this v cos alpha also as u cos theta. Throughout the motion, horizontal component remains unchanged. Why it remains unchanged? Because there is no acceleration along the x-axis. While the vertical component changes because of the acceleration due to gravity which act in downward direction. So we can find the v sin theta using the equation of motion. Let it takes time to reach from A to C in time t. It takes time t, small t, any arbitrary time. So we can write using the equation v equal to u plus at, that v sin theta equal to, it is upward direction, so taken positive. U sin theta is also positive. It is, this is v, this is v alpha. Okay. So v sin alpha equal to u sin theta plus, and acceleration is in downward direction, minus g into t. That means v sin alpha equal to u sin theta minus gt. In this way, we can manipulate the values and can find the desired value. Now we come to the trajectory. We have to find the trajectory of the projectile motion. That means equation in x and y.